Today's topic is acceleration. Acceleration, it is the rate of change of velocity with time. The next term is average acceleration. Average acceleration is denoted by bar over a, and it is equal to delta v upon delta t, that means v2 minus v1 divided by t2 minus t1, or simply average acceleration is change in velocity divided by time interval. Here v1 is the velocity of the object at time t1 and v2 is the velocity of the object at time t2. Next is instantaneous acceleration. It is denoted by a, and it is the limit of average acceleration when time interval approaches to 0. That means limit delta t tends to 0, delta v upon delta t. In the language of calculus, this will become dv by dt. Therefore, instantaneous acceleration a is equal to dv by dt. Next, we have shown two velocity time curves. From this curve, we can find out average acceleration as well as instantaneous acceleration. Look at the 2 points P1 and P2 on the curve, which corresponds to time t1 and velocity v1 and time t2 and velocity v2. Here the slope of the line P1 P2, it gives you average acceleration during the time interval t2 minus t1, and the slope of the tangent at P, it gives you the instantaneous acceleration at point P. Now acceleration is a vector quantity and it can be positive, negative or 0. Next we have shown a few velocity time graphs. The first graph where the velocity is increasing, it corresponds to constant positive acceleration. Here the initial velocity is v0 and after time t velocity is v, which is increasing in magnitude. And in the second graph the velocity is decreasing. This is the case for constant negative acceleration. So whenever the acceleration will be constant, the graph will be a straight line. Remember, if the vt graph is not a straight line but a curve as shown you earlier, then it means that acceleration is not uniform. Also, the slope of the tangent to the vt curve gives us the acceleration at that instant. One more information, the area under the vt curve represents the displacement over a given time interval.